Persistence in Jakarta persistence. Persistence. The Jakarta.persistence class contains statics helper methods to obtain entity manager factory instances in a vendor neutral fashion. Within a container, you will typically use injection to access an entity manager factory. Applications operating outside of a container, however, can use the persistent class to obtain entity manager factory objects in a vendor neutral fashion. Here you can see persistent context collision. Only one persistent context could be propagated with Jakarta persistent Jakarta transaction. The extent persistent context would always try to make itself an active persistent context. This can lead to situations which of the two persistent contexts collide with each other. Consider, for example, that a stateless session bean with the transaction scoped entity manager creates a new persistent context. Then invokes a method on the stateful session bean with the extended persistent context. During the eager associations of the extended persistent context, the container will check to see whether there is already an active persistent context. If there is, it must be the same as the extended persistent context that is trying to associate, or an exception will be thrown. In this example, the stateful session bean will find the transaction scoped persistent context created by the stateless session bean, and the call into the stateful session bean method will fail. There can only one active persistent context for the transaction. This figure illustrates this case. While extended persistent context propagation is useful if a stateful session bean with an extended persistent context is the first enterprise bean to be invoked in a call chain, it limits the situation in which the other components that can call into the stateful session bean if they are also using the entity managers. This might or might not be a common depending on your application architecture, but it is something to keep in mind when planning dependencies between components. One way to work around this problem is to change the default transaction attribute for stateful session bean that uses the extended persistent context. If the default transaction attribute requires new, any active transaction will be suspended before the stateful session bean method starts, allowing it to associate its extended persistent context with the new transaction. This is a good strategy if the stateful session bean calls into other stateless session beans that needs to propagate to the persistent context. Note that excessive use of requires new transaction attribute can lead to application performance problems because many more transactions than normal will be created and the active transaction will be suspended and resumed. If the stateful session bean is largely self-contained, that is, it does not call other session beans and does not need its persistent context propagated, the default transaction attribute of not supported can be worth considering. In this case, any active transaction will be suspended before stateful session bean method start, but two new transaction will be started. If there are some methods that need to write data to the database, those methods can be overridden to use requires new transaction attributes. Here you can see a stateless session bean transaction stateless session bean is connected to stateful session bean via invokes and transaction propagated. Here status session bin interacts with transaction scope persistent context, and here stateful session bin interacts with extended persistence context. Here you can see the collision here. Consider class persistence. Bootstrap class that is used to obtain an entity manager factory in Java SE environments. It may also be used to cause schema generation to occur. This is in module jakarta.persistence and in package jakarta.persistence. Here you can see the as an example too, we can consider this the content of example file persistent.xml. A persistence.xml file defines a persistent unit. The persistence.xml is located in meta-inf directory of the root of the persistence unit. It may be used to specify manage persistence classes included in the persistence unit. It may be used to specify manage persistence classes included in the persistence unit, object relational mapping information for those classes, and scripts for use in schema generation and bulk loading of data and other configuration information for the persistence unit, and for the entity managers and entity manager factory for the persistence unit. This information may be defined by containment or by reference. Here you can, as an example 3, you can see obtaining an entity manager factory in a Java SE environment outside a Jakarta EE container environment. The jakarta.persistent class is the bootstrap class that provides access to an entity manager factory. The application creates an entity manager factory by calling the create entity manager factory method of the Jakarta persistence jakarta.persistence class. The method entity manager factory the method create entity manager factory string persistence unit name here creates and returns an entity manager factory for the named persistence unit. Now we are considering persistent context in entity managers and persistent context. A persistent context is a set of managed entity instances in which for any persistent entity identity there is a unique entity instance. Within a persistent context, entity instances and their lifecycle are managed by the entity manager. In Jakarta EE environments, a JTA transaction typically involves calls across multiple components. Such components may often need to access the same persistent context within a single transaction. To facilitate such a use of entity managers in Jakarta EE environment, when an entity manager is injected into a component or looked up directly in a JNDI context, its persistent context will automatically be propagated with the current JTA transaction, and the entity manager references that are mapped to the same persistent unit will provide access to the same persistent context within the JTA transaction. This propagation of persistent context by Jakarta EE container avoid the need for application to pass references to the entity manager instances from one component to another. The entity manager for which the container manages the persistent context in this manner is termed container managed entity manager. Container managed entity manager's lifecycle is managed by the Jakarta E container. In less common use cases with Jakarta E environment, applications may need to access persistent context that is standalone, that is not propagated along with the JTA transaction across entity manager's references for given persistent unit. Instead, each instance of creating an entity manager causes a new isolated persistent context to be created that is not accessible through the other entity manager references within the same transaction. These use cases are supported by through the entity manager methods of the entity manager factory instance. The entity manager that is used by the application to create and destroy persistent context in this manner is termed as application managed entity manager. An application managed entity manager's lifecycle is managed by the application. Both container managed entity managers and application managed entity managers and their persistent contexts are required to be supported in Java EA web containers and EJB containers. Within an EJB environment, container managed entity managers are typically used. In Java SE environment and Jakarta E application client containers, only application managed entity managers are required to be. Now we are considering examples in container managed persistent context. This is a container managed extended persistent context. The annotation type persistent context in Jakarta persistent in Jakarta module Jakarta persistence express the dependency on a container managed entity manager and its associated persistent context. Container managed extended persistent context. A container managed extended persistent context can only be initiated within a scope of a stateful session bean. It exists from the point in at which the stateful session bean that declares dependency on an entity manager of the type persistent context type dot extended is created and is said to be bound to the stateful session bean. Dependency on extended persistent context is declared by means of persistent context annotation or persistent context ref deployment descript element. The association of the extended persistent context within JTA transaction is independent of the synchronization type of the persistent context and whether the persistent context has been joined to the transaction. Persistent context is closed by the container when the at remove method of the stateful session bean completes or stateful session bean instance is otherwise destroyed. Here the an extended transaction context is used. The entries may remain managed in the persistent context across multiple transactions. Now we are considering examples in application managed persistent context. Here the application managed persistent context used in stateless session bean. When an application managed entity manager is used, an application interact directly with the persistent provider's entity manager factory to manage the entity manager lifecycle and to obtain and destroy persistent context. All such application managed persistent contexts are extended in the scope and can span multiple transactions. the entity manager factory dot create entity manager method and the entity manager clause and is open method are used to manage the lifecycle of the application manager entity manager and its associated persistent context. Extended persist context exists from the point at which the entity manager has been created using entity manager factory dot create entity manager until the entity manager is closed by the means of entity manager dot close. An extended persist context obtained from the application manage entity manager is a standalone persistent context. It is not propagated with the transaction. When JTA application manage entity manager is used, then application manage persistent context may be applied to be type of synchronization type dot unsynchronized. Persistent context of type synchronized type dot unsynchronized is not enlisted in any JTA transaction unless explicitly joined to the transaction by application. The persistent context type synchronized type dot unsynchronized is enlisted in JTA transaction and registered with subsequent transaction notification against the transaction by invocation of entity manager join transaction method. The persistent context remain joined to the transaction until the transaction commit and or rollback. After transaction commit or rollback, the persistent context will not be joined and any subsequent transaction unless the joint transaction method is invoked in the scope of the subsequent transaction. When JTA application manage entity manager is used, if the entity manager is created outside the scope of the current JTA transaction, it is responsibility of the application to join the entity manager to the transaction if desired by calling entity manager dot join transaction. If the entity manager is created outside the scope of JTA transaction, it is not joined to the transaction unless entity manager dot join transaction is called. Entity manager dot close method closes the entity manager and to release its persistent context and other resources. After calling close, the application must not invoke any further methods on the entity manager instance except for get transaction. Except for get transaction and is open, or the illegal state exception will be thrown. If the close method is invoked when the transaction is active, the persistent context remain managed until the transaction completes. The entity manager is open method indicates whether the entity manager is open. The is open method returns are true until the entity manager has been closed. This is container managed transaction demarcation issues. The session bean creates and closes an entity manager in business method. In each business method. Here persistent unit notation. Remains managed until JTA transaction ends. Now we are considering application managed persistent context in requirements on the container. The container might use the internal APIs to create entity manager factory, or it might use the persistent provider.create contain entity manager factory method. The interface persistent provider in package jakarta.persistent.spi in module jakarta.persistence interface implemented by the persistent provider. When application managed persistent context are used, the container must initiate the entity manager factory and expose to the application via JNDI. The container might use the internal API to create the entity manager factory, or it might use the persistent provider.create a container entity manager factory method. However, the container is required to support third-party persistent providers, and in this case, the container must use the persistent provider.create contain entity manager factory method to create entity manager factory, and the entity manager factory.close method to destroy the entity manager factory prior to the shutdown if it is not it has not been previously closed by the application. Now we are considering provider responsibilities in runtime contract between container and persistent provider. It provides entity managers to the container when requested and registered for transaction synchronization notifications. The provider has no knowledge of the distinction between the transaction scoped and extended persistent context. When entity manager factory.create entity manager is invoked, the provider must create and return a new entity manager. If a JTA transaction is active and the persistent context is the type of synchronization type.synchronize, the provider must register for the synchronization notification against the JTA transaction. When entity manager.join transaction is invoked, the provider must register for synchronization notification against the current JTA transaction if a previous joint transaction invocation for the transaction has not already been processed. When the JTA transaction commit, if the persistent context is of the type synchronization type.synchronize or has otherwise been joined to the transaction, the provider must flush all modified entity state to the database. When the JTA transaction rollback, the provider must detach all managed entities if the persistent context of the type synchronization type.synchronize or has otherwise been joined to the transaction. Note that the JTA transaction may roll back in the background thread, for example, as a result of transaction timeout, in which case the provider should arrange for the managed entities to be detached from the persistent context but not concurrently while application is on the entity manager invocation. When the provider throws an exception defined to cause transaction rollback, the provider must mark the transaction for rollback if the persistent context is of type transaction type synchronization type.synchronize or has otherwise been joined to the transaction. When the entity manager.close invoked, the provider should release all resources that may have been allocated after outstanding transaction involving the entity manager have completed. If the entity manager was already in a closed state, the provider must throw the legal exception. When entity manager.clear is invoked, the provider must detach all managed entities. Now we are considering cache interface. The cache interface provides basic functionality over the persistent provider's second level cache if used. Interface cache in package jakarta.persistent in module jakarta.persistence. Interface is used to interact with the second level cache. If a cache is not in use, the method of this interface have no effect except for contains, which return false. Now we are considering persistent unit util interface. The behavior is undefined if these methods are invoked on an entity instance that is not associated with the persistent unit from whose entity manager factory this interface has been obtained. Persistent unit util interface provide access to utility methods that can be invoked on entities associated with the persistent unit. The interface persistent unit util in package jakarta.persistent in module jakarta.persistence. Utility interface between the application and the persistent provider managing the persistent unit. Now we are considering persistent unit in entity packaging. A persistent unit is a logical grouping that includes an entity manager factory and its entity managers together with their configuration information. Set of managed classes included in the persistent unit and managed by the entity managers of the entity manager factory. Mapping metadata in the form of metadata annotations and or XML metadata that is specified the mapping of the classes to the database. Now we are considering a persistent.xml file in persistent unit packaging. Here you can see example. Persistent.xml file define the persistent unit. Persistent.xml file located in the meta-inf directory of the root of the persistent unit. It may be used to specify manage persistent classes including the persistent unit. It may be used to specify manage persistent class including the persistent unit, object relation mapping information for those classes, scripts for use for schema generation and bulk loading data. Another configuration information for persistent unit and for the entity managers and entity manager factory for persistent unit. This information may be defined by the container or by reference. Object relational mapping information can be in the form of annotations on the managed persistent classes including the persistent unit, and ORM .xml contains the meta-inf directory of the root of the persistent unit, one or more XML files on the class path and referenced from the persistent unit or combination of these. Managed persistent classes may either be contained within the root of the persistent unit or they may be specified by reference, that is by naming the classes, class archives, or XML mapping files which turn the reference classes. That are accessible on the application class path or may be specified by some combination of these means. The root element of the persistent.xml is the persistent element. The persistent element consists one or more persistent unit elements. Persistent unit element contains name, transaction type, attributes, and the following sub-element: description, provider, JTA data source, non-JTA data source, mapping file, jar file, class, exclude unlisted classes, shared cache mode, validation mode, and properties. The name attribute is required. The other attributes and elements are optional. The semantics are described. You can see the examples here. The name attribute defines the name of the persistent unit, and this name may be used to identify persistent unit referenced by the persistent context and persistent unit annotations, and in the programmatic API for creating the entity manager factory. Transaction type is not shown here. Transaction type attribute is used to specify whether the entity managers provided by the entity manager factory for the persistent unit must be JTA entity managers or resource local entity managers. The value of the element is JTA or resource underscore local. Transaction type JTA assumes that the JTA resource JTA data source will be provided and either specified by the JTA data source element or provided by the container. In general, the Jakarta E environments, the transaction type of resource underscore local assumes that non-JTA data source will be provided. In Jakarta E environment, if this element is not specified, the default is JTA. In Java SE environment, if this element is not specified, the default is resource underscore local. Description. The description element provides optional descriptive information about the persistent unit. Provider. The provider element specifies the name of the persistent provider's jakarta.persistent.spa.persistent provider class. The provider element is optional, but should be specified if the application is depending upon the particular persistent providing being used. JTA data source and non-JTA data source. In Jakarta E environments, the JTA data source and non-JTA data source elements are used to specify the JNDI name and of the JTA and or non-JTA data source to be used by the persistent provider. If neither is specified, the deployer must specify the JTA data source at the deployment, or default JTA data source must be provided by the container, and the JTA entity manager factory will be created to correspond to it. In Java SE environment, these elements may be used or data source information may be specified by the other means depending upon the requirement of the provider. Mapping file, jar file, class, and exclude unlisted classes. The following classes must be implicitly or explicitly denoted as managed persistent classes to be included within the persistent unit. Entity classes, embedded classes, super classes, converter classes. Set of managed persistent classes that are managed by the persistent unit is defined by one or more of the following. Annotated managed persistent class contained in the root of the persistent unit, unlike exclude unlisted classes element is specified. One or more object relational mapping XML files. One or more jar files that will be a search for classes, and an explicit list of classes. The set of entities managed by persistent unit is a union of these sources with the mapping metadata annotation. So annotation default for a given class being overridden by XML mapping information file if there are both annotations as well as XML mappings for the class. Minimum portable level of overriding is at the level of the persistent field or property. Class and or jar files are named as part of the persistent unit must be on the class path. Referencing them from the persistent.xml file does not cause them to be placed on the class path. All classes must be on the class path to ensure that the entity managers from the different persistent unit that map the same class will be accessed the same identical class. Shared cache mode is not shown here. The shared cache mode element determines whether the second level cache is in effect or not. In effect for the persistent unit. Validation mode element determines whether the automatic lifecycle event time validation in effect. Properties element is used to specify both standard and vendor specific properties and hint to that apply to the persistent unit and its entity manager factory configuration. This section provides the schema XML schema for the persistent.xml file here and etc. We are considering Jakarta E deployment in container and provider contracts for deployment and bootstrapping. Once the container has read the persistent metadata, it determines the Jakarta SVI persistence provider implementation for class for each deployed named persistent unit. Interface persistent provider in package jakarta.persistent.spi in module jakarta.persistent. It is invoked by the container in the Jakarta environment and by the persistent class in the Java SC environment to create an entity manager factory and or to cause schema generation to occur. Each persistent unit deployed into Jakarta E container consists of a single persistent.xml file, a number of mapping files, and a number of class files. At deployment time, the container is responsible for scanning the locations and discovering the persistent.xml files and processing them. When the container finds the persistent.xml file, it must process the persistent unit definitions that it contains. The container must validate the persistent.xml file against the persistence 30.xsd or persistent22.xsd schema in accordance with the version specified by the persistent.xml file and the report any validation errors. Provider or data source information not specified in the persistent.xml file must be provided at deployment time or defaulted by the container. The container may optionally add any container specific properties to be passed to the provider when creating the entity manager factory for the persistent unit. Once the container has read the persistent metadata, it determines the jakarta.persistent.spa.persistent provider implementation class for each deployed named persistent unit. The container then creates an instance of the persistent provider implementation class for each deployed named persistent unit and invokes a create container entity manager factory method on that instance. Container must implement the persistent unit info interface and pass metadata in the form of a persistent unit info instance to the persistent provider as part of this call. If the bean validation provider exists in the container environment and the validation mode none is specified, the validator factory instance must be made available by the container. The container is responsible for passing the validator factory instance via the map that is passed as an argument to the create container entity manager factory call. The map key used to be must be the standard property name jakarta.persistent.validation.factory. If CDI is enabled, the bean manager instance must be made available by the container. The container is responsible for passing this bean manager instance via the map that is passed as an argument to the create container entity manager factory call. The map key used must be the standard property name jakarta.persistent.bean.manager. The entity manager factory instance obtained as a result will be used by the container to create container managed entity managers. If one entity manager factory is permitted to be created for each deployed persistent unit configuration, a number of entity manager instances may be created from the given factory. In Jakarta E environment, the classes of the persistent unit should not be loaded by the application class loader or any of its parent class loaders until after entity manager factory for the persistent unit has been created. When a persistent unit is redeployed, the container should call the close method and on the previous entity manager factory instance and call the create container entity manager factory method again with the required persistent unit info metadata to achieve the redeployment. Now we are considering bootstrapping in Java SC environment. Here the example, the jar include the provider configuration file. In Java SC environment, the persistent.create entity manager factory method is used by the application to create entity manager factory. A persistent provider implementation running in a Java SC environment should also act as a service provider by supplying a service provider configuration file as defined by the Java SC platform. The provider configuration file serves to expose the provider implementation class to the persistent bootstrap class, positioning provider as a candidate for backing named persistent unit. The provider supplies the provider configuration file by creating a text file named jakarta.persistent.spi.persistent provider and placing in the meta-inf services directory of one of its jar files. The content of the file should be the name of the provider implementation class of the jakarta.persistent.spi.persistent provider interface. Example here, a persistent vendor called ACME persistent product ships in a jar called acme.jar that contains its persistent provider implementation. The jar includes the provider configuration file. The content of the meta-inf services jakarta.persistent.spi.persistent provider file is nothing more than the name of the implementation class com.acme.persistent provider. Persistent provider jars may be installed or made available in the same ways as other service providers, for example extensions or added to the application path. Persistent bootstrap class must locate all the persistent providers using persistent provider resolver mechanism and call create entity manager factory on them in turn until an appropriate backing providers return the entity manager factory instance. Provider may deem itself as appropriate for the persistent unit if any of the following are true. Implementation class has been specified in the provider element for that persistent unit in the persistent.xml file and has not been overridden by the different jakarta.persistent.provider. Property value included in the map passed to the create entity manager factory method. The jakarta.persistent.provider property was included in the map passed to the create entity manager factory, and the value of the property is provider implementation class. No provider was specified for the persistent unit in either the persistent.xml or property map. If the provider does not qualify as a provider for the named persistent unit, it must return null when create entity manager factory is invoked on it. Now we are considering determining the available persistent providers. The persistent provider resolver and persistent provider resolver holder mechanism support the dynamic discovery of persistent providers. The persistent provider resolver instance is responsible for returning a list of providers available in the environment. Here the interface persistent provider resolver in package jakarta.persistent.spi in module jakarta.persistence. Determine the list of persistent providers available in the runtime environment. Class persistent provider resolver holder in package jakarta.persistent.spi in module jakarta.persistence. Hold the global persistent provider resolver instance. If no persistent provider resolver is set by the environment, the default persistent provider resolver is used. Enable jakarta.persistent.spi logger to show diagnostic information. Implementations must be thread safe. Persistent provider resolver instance is responsible for returning a list of providers available in the environment. Persistent provider resolver holder class hold the persistent provider resolver instance that is in use. The implementation of persistent provider resolver holder must be thread safe, but no guarantee is made against a multiple thread setting the resolver. Container is allowed to implement and set a specific persistent provider resolver provided that respect the persistence provider resolver contract. Persistent provider resolver instance is to be used to set the is set by the container using the persistent provider resolver holder set persistent provider resolver method. If no persistent provider resolver is set, the persistent provider resolver holder must return a persistent provider resolver that returns the providers whose persistent provider jars has been installed or made available as service providers and extensions. The default persistent provider resolver instance does not guarantee the order in which the persistent providers are returned. Persistent provider resolver must be thread safe. Persistent provider resolver dot get persistent providers method must be used to determine the list of available persistent providers. The result of calling persistent provider resolver holder dot get persistent provider resolver and the persistent provider resolver dot get persistent providers method must not be cached. In particular, the following method must use the persistent provider resolver instance returned by the persistent provider resolver holder dot get persistent provider resolver method to determine the list of available providers. Persistent dot create entity manager factory string. Persistent dot create entity manager factory string map. Persistent util dot is loaded object. Persistent util is loaded object string. This method must not cache the list of providers and must not cache the persistent provider resolver instance. Note that the persistent provider resolver dot get persistent providers method can potentially be called many times. It is therefore recommended that the implementation of this method make use of caching. Note that only single persistent provider resolver instance can be defined in a given class loader hierarchy at given time. Now we are considering Jakarta.persistent.schema-generation.database.action in schema generation. The Jakarta.persistent.schema-generation database.action property specifies the action to be taken by the persistent provider with regard to the database artifacts. The values for this property are none, create, drop, and create, drop. If the Jakarta persistent schema generation database action property is not specified, the schema generation actions must be taken on the database. Now we are considering the Jakarta.persistent.spi.persistent provider in responsibilities of the persistent provider. The persistent provider implementation class must have a public no arg constructor. The interface persistent provider in package Jakarta.persistent.spi in module Jakarta.persistent. The interface implemented by the persistent provider. The interface Jakarta.persistent.spi.persistent provider must be implemented by the persistent provider. It is invoked by the container in the Jakarta E environment and by the Jakarta.persistent.persistence class in the Java SC environments. The Jakarta.persistent.spi.persistent provider implementation is not intended to be used by the application. The persistent provider implementation class must have a public no arg constructor. The properties used in the create entity manager factory method in Java SC environment are described in the documentation. You can refer it. Now we are considering Jakarta.persistent.spi.persistent unit info interface. Interface persistent unit info in package Jakarta.persistent.spi in module Jakarta.persistence. Interface implemented by the container and used by the persistent provider when creating an entity manager factory. Now we are considering persistent util interface. The semantics of the method of this interface are defined. The interface persistent util in package Jakarta.persistence in module Jakarta.persistence. Utility interface between the application and the persistent providers. This interface is used to determine the load state. Now we are considering evicting an entity instance from the persistent context in entity instance lifecycle and entity operations. The semantics of the detach operation applied to an entity X as follows. The entity instance is removed from the persistent context by invoking detach method on it or cascading the detach operation. Changes made to the entity and if any including removal of the entity will not be synchronized to the database after such eviction has taken place. Applications must be flushed method use the flush method prior to the detach method to ensure the portable semantics. if changes have been made to the entity, including removal of the entity. Because the persistent provider may write to the database at times other than the explicit invocation of the flush method, portable applications must not assume that changes have been written to the database if the flush method has not been called prior to detach. The semantics of the detach operation applied to an entity X are as follows. If X is a managed entity, the detach operation causes it to become detached. Detach operation is cascaded to entities referenced by X if the relationship from X to these entities is annotated with the cascade equal detach or cascade equal all annotation element value. Entities which previously referenced X will continue to reference X. If the X is a new or detached entity, it is ignored by the detach operation. If the X is a removed entity, the detach operation causes it to become detached. Detach operation is cascaded to entities referenced by X if the relationship from X to these other entities is annotated with the cascade equal detach and cascade equal all annotation element value. Entities which previously reference X will continue to reference X. Portable applications should not pass removed entities that have been detached from the persistent context to further entity manager operations. Now we are considering persistent context lifetime and synchronization type in entity operations. The persistent context lifetime scope is defined when the entity manager instance is created, whether explicitly or in conjunction with injection or JNDI lookup. Enum persistent context type in package Jakarta.persistent in module Jakarta.persistence specified whether a transaction is scoped or extended persistent context is to be used in persistent context. If not specified, the transaction is scoped persistent context is used. The lifetime of a container managed persistent context can either be scoped to a transaction is scoped persistent context, or have a lifetime scope that extend beyond that of a single transaction extended persistent context. The enum persistent context type is used to define the persistent context lifetime scope for a container managed entity managers. Persistent context lifetime scope is defined when the entity manager instance is created, whether explicitly or in conjunction with the injection or JNDI lookup. By default, the lifetime of a persistent context of a container managed by the entity manager correspondent to a scope of a transaction, that is, it is of type persistent context type dot transaction. When an extended persistent context is used, the extended persistent context exists from the time the entity manager instance is created until it is closed. This persistent context might span multiple transactions and non-transactional invocations of the entity manager. And an entity manager with an extended persistent context maintain its reference to the entity object after a transaction has committed. Those objects remain managed by the entity manager and they can be updated as managed objects between transactions. Navigation from managed object in an extended persistent context result in one or more other managed object regardless of whether a transaction is active. When an entity manager with an extended persistent context is used, the persist and remove, merge and refresh operations can be called regardless of whether the transaction is active. Effect of these operations will be committed to the database when the extended persistent context is enlisted in a transaction and transaction commits. The scope of the persistent context of an application managed entity manager is extended. It is responsible for the application to manage the lifecycle of the persistent context. Container managed persistent context are described further in the documentation, and persistent context managed by the applications are also described further in the documentation. Now we are considering persistent default sub-elements in XML overriding rules in XML object relational mapping descriptor. Schema. The schema of a sub-element applies to all entities, tables, secondary tables, join tables, collection tables, table generators, and sequence generators in the persistent unit. The schema sub-element is overridden by the schema sub-element of the entity mapping element, any schema element explicitly specified in the table or secondary table annotation on an entity, or any schema attributes on any table or secondary table sub-element defined within the element entity element, any schema element explicitly specified in the table generate annotation or table generate sub-element, any schema element explicitly specified in the sequence generate annotation or sequence generate sub-element, any schema element explicitly specified in the join table annotation or join table sub-element, and any schema element explicitly specified in the collection table annotation or collection table sub-element. An example, we can consider persistence exception. If insufficient or inconsistent configuration information is provided, or if schema generation otherwise fails in method generate schema string persistent unit name map in class persistence.